All right, welcome back to the lab session. Let's get started. Over here, we're going to actually try and then understand the various concepts that we learned throughout from the introduction to clustering all the way to K-means clustering. All right, so we're going to implement specifically for K-means clustering, and then in the subsequent videos, we also talk about hierarchical clustering and how we're going to implement that. Okay, so in this particular video, we're going to consider K-means clustering, and then we're going to practically see how we will implement this K-means clustering, okay, and the various concepts that we have learned with respect to choosing the K and in the elbow method and the Leos theorem and all those stuff, okay. So let's see how we're going to implement this over here. So we're going to use this technical support data, right? So if you can see over here, right, we have a technical support data that we are going to actually use in this particular case. So if you consider any company, for instance, right, if they give any product out there for sale, right, if they produce any product for sale, normally what they do is that they have a technical support session where if you have any problem, right, you just some people call it complaint session, right, or complaint center, right. So they have that session that people will go there. I mean, it will call. So normally it's just a phone call, and then you lodge your complaint, and then the technical support will actually assist you. Or maybe it could be on email. You send them an email, and then they will respond to you, right? So most of the companies have a technical support center, right? And this is one of the data that has been collected with regards to these technical complaints that people were lodging with respect to certain products, right? So we're going to see some of the complaints as we load our data set, right? We're going to see some of them, and then try to cluster these complaints into common complaints, right? Into similar complaints, right? Just that's what clustering normally does, right? So that's what we're going to do using the K-means. Okay, so let's proceed and then see how we're going to go about this, right? So normally what you do is to load the various libraries that you're going to need, right? So in this case, we are loading all the familiar libraries that you already know about. So the likes of pandas and numpy and matplotlib and matplotlib inline to plot our graphs inside the notebook, and then Seaborn for visualization, right, which is built on top of the matplotlib. And then we also have what is called the cluster, right? So from sklearn, there's cluster which is present in sklearn, right? And then in that we are importing our k-means, right? So this the one that we've not worked with so far. I mean, z-score, we've worked with z-score in our previous videos, right? So just to scale our data, we're going to use z-score, right? And we're going to see how we're going to do that, just like we did it in the previous videos, right? So the only one that we've not worked with so far is this k-means, right? And that's what we're going to use moving on from here. Okay, so these are our libraries. These are the libraries that we're going to use. Now, after that is done, right, after our libraries are done, after we've imported our libraries, the next thing to do is to load our data set, okay? And that's what you're going to do over here. So this data set is actually stored in a CSV format, right? Stored in a CSV format. So in that case, I'm going to use the read underscore CSV to read it, right, which is present in pandas, right? So I'm going to use read underscore CSV present in pandas to read this data set, and then I'll store everything in a variable called text support df, right? This is just a variable name that I chose, which you can choose any any variable name, right, as you load this data, because I'm going to load this data on the platform for you so that you can also load and then work alongside. All right, so you can name it any variable name that you want over here. This is just a name that I prefer to use. So by the way, as I said, if you're naming if you're naming variables, right, in your program, you have to make sure that whatever you're doing actually makes sense, and whenever you encounter it again in your program, you can actually identify. So in this case, I'm using text sub in df to represent my text support data frame, right? So if I see it anywhere, I'm able to identify this is my original data, which contains my text support data, right? So I'll be able to identify that. All right, so now that part is done. Let's see the next step that we can actually take. So we're going to see the number of rows and columns that we have with regards to this text support data, right? So if we do that, you can see that we have 23 records with 8 different columns that we have, right? All right, so let's try and then see what is contained in this data, right? So if we actually see what is contained, don't forget that we stored everything in a variable called text support. Text sub underscore df, right? So if we see what is inside the text sub underscore df, I'm going to print everything, right? So let me get rid of this. Okay, so now if we do that, right? If we do that, you see that this is what we have in here, right? So these are the various complaints that people actually lodge to the technical support session, right? So you can see we have the problem type, right? We have the problem type, we have number of cases, we have the average pending calls, right? So let's actually take it from here, and then we can actually go into these columns one by one. All right, so if you see the problem type, you can see we have different problem types in here, right? So you can see temperature control not working, right? Power cord does not tightly fit. We have fan swing not working. We have main switch does not turn on. We have forgot mobile app password, AC stop abruptly. We have app hangs while entering commands. We have app takes a long time to initialize. So a lot of complaints that people call in and then lodge these complaints, right? So you can see Wi-Fi connectivity breaks. So a lot of complaints, right? And then over here you can see the number of cases. So if we take temperature control not working, for instance, 170 of that cases were reported, right? So those number of cases were also recorded. Then the average pending calls, that is how on average how people call for to lodge these complaints, right? And then we have the on average the resolution time, how long the technical support team take to actually resolve these issues, right? So on average, it's being recorded here. The average resolution time is being recorded here, all right? Then we have the recurrence frequency. That is how often the same problems keep on coming in over and over, right? And then we have the replacement percentage. That is how the percentage of the technical support, replacing these faults. If for instance, if they say fan swing does not on, right? How often they replace this fan swing, right? So that's also being recorded over here. And then we have the in warranty and then the post warranty, right? That's before and the after warranty over here. All right. So all these complaints have been recorded and have been actually collected as a whole data for us, and that's what you're going to work on to actually see if we can group or cluster these complaints into similar complaints, right? If we can cluster these complaints into similar complaints, if we see AC stopped abruptly, AC control software missing, AC remote does not work. So all these are complaints that are related to AC, right? So can we group these complaints into one group so that the technical support can assign a person, an expert who is, someone who is expert in dealing with AC they can assign that person to this kind of complaint and the person will work on that. All right, can we do that? And that's what we are actually going to do over here, right? So complaints that are similar, we will be able to group them into similar groups so that the management can assign, or the technical support team can assign a person to deal with that. Okay, let's proceed after we've seen our data, after now we are familiar with our data, right? So I'm going to divide the data into I'm going to select the ones that I'm going to work on. With the exception of the complaint column, right? With the exception of the complaint column, I'm going to select everything, right? So if you see what I'm doing over here, right? I'm just selecting all the rows, and then I'm starting from the first column to the last, right? So that's basically what I'm doing over here, right? So what I'm saying is that I'm selecting this, right? With exception of this column, right? This is actually 0, and then 1, 2, 3, 4, 5, 6, all the way to the 7th one. So with the exception of this, right, I'm going to select everything here, right? I'm going to select everything here, right? That's what I'm going to work on, because I don't need this one to work on. I need these attributes, right, to be able to cluster these, right? To be able to cluster these. So I'm going to work on these attributes to make sure that these attributes will help me to cluster these complaints into similar complaints. Okay, so let's proceed with that and then see how well we will be able to go about this. Okay, so over here I'm selecting that. So with the exception of the first, I'm selecting all rows, and then from the first to the last column. Then after that, so I'm going to scale it. I'm going to apply the z-score on remember that when I selected it, I store everything in a variable called text sub attribute, right? That's the text support attribute, right? So it's just a variable name, but I'm making it familiar so that I will know what I'm selecting over here. So it's just a text support attribute, all right? Then I scale it and I store it in another variable called text support scaled, right? And I know by now you know why we're applying the z-score, right? If you watch the previous video, you understand why we need to scale our data, right? So just brush off, right? Just to brush off, let's just see how our data is and why we are scaling it over here, right? So if you see what we have in here, right? Let me bring this pen. If you see what we have in here, you can see that we have some values which are very large, and then we have some values which are very small, right? Very small, right? Even if you consider this, you can see that some are very small, some are even zero, but some are very large, right? So this is very inconsistent. They are not, I mean, they are not on the same scale, right? It's very inconsistent over here. So we want to bring them all of them on the same scale, right? We want to bring all of them on the same scale, and z-score is one of the ways that you can actually use to bring your data into the same scale, right? The z-score is one of them, right? So basically, that's what we're actually going to use the z-score to actually scale this data so that they will all be on the same scale, all right? So that one data point will not overscale the other, right? So if we find the distance between, say, 170 and 12, right, it's going to be a huge distance. It's going to be a huge distance, and if we square this again, then it's going to be very huge. As against if we find the distance between, say, 0.00 and then 50, right, it's actually going to be very small, right? It's going to be small as compared to this, even if we square it, right? Don't forget that that's what the Euclidean distance will help us to do, right? Find the square root of this. That's what it will do. Okay, so in order for one distance not to outweigh the other, right? Not to outweigh the other, we bring all of them to the same scale, right? To the same level, so that we can actually work on it from here. All right. So I hope in the previous videos you got an intuition of why we needed this. So this is just to brush it off. All right. Now, after we apply this z-score on it, right, we store everything in what is called the text sub scaled. That's going to show me that I've scaled my data, right? I've scaled my text sub attribute data, and I've stored it in another variable called text sub scaled. All right. Now this is done. Let's proceed and then see how we can do this Pep Plot over here, right? So let me just run this. I'm going to run this all the way from here, right? So let me run this again. Okay. All right. So let me run this. Let me run this part. All right, and then I'll show you the Pep Plot. Okay, so this is the output of the Pep Plot that we have over here, right? So you can see that the correlation that is existing among these is very low among the various attributes, right? We don't actually have the attributes to be correlated, and of course that is understandable because number of cases, we don't expect number of cases maybe to be related to maybe the in-warranty percent. I mean, somehow there might be some small correlation there, but I mean, it's going to be quite low, right? It's going to be quite low over here, as you can see, right? So in this one, we will not worry ourselves with the problem of multicollinearity. We will not actually worry ourselves with that. Okay, so now let's proceed from here. Since our data is clean, we can now work on it. Now, if we want to build our algorithm, right? If we want to build our k-means algorithm, what we need to do is to choose the k, right? We need to choose our k, right? And as we talked about when we're dealing with, getting to understand the intuition behind that on the whiteboard, we talked about the elbow method, right? If you remember this demonstration over here, right? We talked about the elbow method, right? We talked about the elbow method. So I'm sure you have a little bit idea about that. So in order for us to know what k to choose, right, we are going to use the elbow method over here. We are going to use the elbow method over here, right? So let's see how we are going to deal with this elbow method, right? Let's see how we're going to deal with it. So over here, right, with the code that you have, let me minimize a little bit. right? So that we can have everything here, right? So that we can have everything here. Now, if you see what I'm importing, right? So first, what I'm importing here is this what is called the C dist, right? What is called the C dist here. The C dist is nothing but it's actually going to compute the distance between each pair, right? Remember that we are using Euclidean distance. So if we go here, right? If we come here, the distance between let me get rid of that, right? The distance between each of the points, right? The distance between each of the points here, right? It's actually going to be considered, right? So maybe the distance between the point and then the centroid over here, right? The centroid over here is actually going to be computed, right, for us. So that's what we need the C dist to actually do. So in order for us to use the Euclidean distance to calculate that distance, right, we're going to use the C dist, which is going to help us to actually do that, okay? To help us to actually do that. Now, I'm creating this clusters, right? So I don't know how many clusters that I want to choose, right? So I can choose my k equals 1, I can choose my k equals 2, I can choose my k equals 3, I can choose my k equals 4. I don't actually know. So I'm just choosing any k. I'm giving a range of k equals 1 all the way to k equals 10, right? K equals 10. So as you can see over here, that's the range that I'm giving, right? That's the range that I'm giving. Then I'm creating an empty list, right? Empty list called mean distortion. So we're going to see what we're going to put into this mean distortion in a while, right? We're going to see what we're going to put in there. Now, what I'm saying is that for k in clusters, remember that my clusters contains a range of numbers from 1 to 10, right? So for k in clusters, right? For k in clusters, what I'm going to do is that normally when you import your k-means, when you load your k-means algorithm, right? Whether import or load, either of them. So when you load, right, when you load your k-means algorithm, what you have to do is to initialize it, right? To initialize it. So that is what we are doing over here. If you remember from all the other algorithms that we've been dealing with so far, right? We initialize it, and then after that we actually fit it, right? That is, make it learn on our training data, right? We make it learn on our training data. So in this case, we need to specify the number of clusters, right? Which is the k. We need to specify the k, but we don't know the specific k. That's why we are using for k in clusters. So this k is going to be from 1 all the way to 10, right? So for k equals 1, k equals 2 all the way to k equals 10, right? So we're going to try several k's and then see which k is going to work for us, okay? Then after that we have our model, right? After that we can now use our model to learn from the training data, or in this case we only have the text scaled data over here, so we're just using that without dividing it into training or testing, okay? Then we can, after that we can make some predictions, right? Now let's see what we have down here, right? Let me clear the screen and then do this. Let's see what we have over here, right? So what I'm doing over here is that I'm going to, let me start from here, right? Remember that we said that we want to minimize, right? We want to minimize the within group sum of squares. Within group variance, right? If you remember here, right? We said that we want to minimize this, which is the within group variance. So that's basically what we are doing here, right? That's basically what we are doing here. If you see here, we have mean here. And we are using the C dist, right? Remember that I told you the C dist is going to calculate the distance between each point. So the distance between each point in our text subscaled, right? This is our data. So the distance between this data and the cluster, right? That's the centroid. That's the if you do model.clusters, right? You're actually going to get the various clusters, right? You're going to get the various clusters. So that's actually going to come from here. So if you use model.fit over here, we are going to get the various clusters based on this, okay? So we are going to calculate the distance between each point in this, right? So if we pick the first point, maybe the first point will say 170. What is the distance between 170 and the number of clusters, that cluster that we have over here? So C dist is actually going to help us calculate that using the Euclidean distance, okay? Using the Euclidean distance. That's why you can see Euclidean distance over here, right? So we use the Euclidean distance to actually do that. All right, we use the Euclidean distance. Now, don't forget that if you see the formula over here, right? Let me get rid of that. If you see the formula over here, we still divide by that, right? that is averaging everything, right? That's averaging everything. So that's why you can actually see us dividing it by this, right? And then I'm using dot shape over here so that I'll be able to have a flat. I'll be able to have this flat. Let me actually show you what I mean by that. Let me actually show you what I mean by that and why I did that. So let me open this. I'll talk about this in a moment. So yeah, now you can see that I'll be able to plot it because I was able to flatten it, right? I was able to flatten it. This is the result. This is the result after we put everything in the mean distortion. This is the result that we have, right? So I'll be able to plot this one over here, right? That's why I wanted to flatten it into a single array over here, right? As you can see, right? So after I do this, right? After I do this, right? I append, right? So I find the sum of that. Don't forget that it's a sum, right? Don't forget that in our formula we have sum here, right? So we sum everything, right? We sum everything. Then we append, right? We append everything to mean distortion. So we created this empty list. So after everything is done, right? After everything here is done, right? After everything here is done, right? After everything here is done, we now add everything inside this empty list. Okay, that's why we are using this append to append it to mean distortions, right? So we append it to mean distortions. All right, so now if we see what is inside the mean distortions, right? We see what is inside the mean distortions. You can see that we have the various measures, right? The various distance measures that we have inside here, right? So all these have been we've been able to calculate this, right? We've been able to calculate these various variances, right? These various variances in here, right? So what we want to do is to actually plot this, right? To plot this against the clusters, right? Plot the mean distortions against the clusters, right? We want to do that, and then we will be able to know, just like we did over here, right? Just like we did over here, we're having the clusters, right? We're having the clusters down here, right? That's the number of k's, right? And then we're having our mean variance, right? The various variance that we have, we plotted them here. Okay, so the same thing that we're going to do, over here. So these distortions that we got, right? These mean distortions that we got, we have them here, right? We plotted them here, right? And that's why earlier on I wanted to flatten it so that I can plot them here, right? And then we have the various clusters, right? All the way from 1 to 9, right? Don't forget that we gave a range of, right? We gave a range of k to be from 1 to 10, right? From 1 to 10. And I always tell you that the last one will not come. It's always 1 minus the last one minus 1. So from 1 to 10 is going to be from 1 all the way, like 1, 2, 3, 4, 5, 6, 7, 8, and then 9, right? That's what it's going to give us. If you want the 10 to come, then you have to go, then here you could have changed it to 11 so that the 10 will come. Okay, so it's always one less than the last one. So yeah, and that's why you can see 9 over here. Now the first k, right? When we choose k to be 1, right? Let me actually push this a little bit up. Okay, so if we choose k to be 1, right? If we choose k to be 1, we can see that the variance is somewhere here, which is very high, right? If we choose k to be 2, you can see that it's now dropping, right? It's now dropping here. It's now dropping, and if we choose k to be 3, you can see where it is right now. It is how it is was tipping from top here all the way. You can see that now the direction is changing, right? It's changing a bit. The steepness is getting a bit low, right? And it went to this point at where k equals 4, and then it started becoming a little bit steep again, right? At where k equals 5, right? And then it started becoming slow again. All right, so the steepness reduces again from here. Okay, now let me just maybe give you a little bit walkthrough of this code before we give a conclusion here. Right now, what I'm doing here is that I'm just going to plot. I'm plotting this clusters, right? I have my clusters, which is this, my clusters, and then my mean distortion, which is this one you can see over here, and then this one you can see bx dash here is just this blue x, and then the dash line that you can see, right? So that's what you can see over here, and then my plt dot x label, that's in matplotlib, right? I'm labeling the x-axis, right? I'm labeling the x-axis to be k, and that's what you can actually see over here. Okay, and then the y-axis, right? I'm using the same matplotlib to label it as mean distortions, right? So it's actually let me, if I do this, you can see that it's there, right? You can see mean distortion over here, right? You can see that it's been plotted over there, and then you can see plc.title, right? And I'm doing selecting k with the elbow method, right? And that's what you can see over here. All right, so now if you look at it critically, right, let me clear this screen, and then you can see it here. Now you can see that it was actually dropping, right? And then when it got to this point, right, so from this point it started, the steepness started reducing, right? The steepness started reducing. So maybe I can say that this is where my elbow is, right? This is where my elbow. Remember that I compare this to your normal elbow, where you'll be having your arm something like this, right? You'll be having your arm something like this with just maybe your fingers, right? So we want where the elbow will actually appear, and that's where we want to actually select. All right, so if you can see this, maybe I can say that, okay, at where my k equals 3, that is where my elbow is, right? That's where my elbow is. So maybe if I select k equals 3, it will actually work for me, right? Maybe someone can also argue that no, after that, the thing is still steep. The steep is still high until when it goes to say 5, before it started reducing. So maybe I should also try k equals 5, right? So let's just try these two and then see which one will actually work better for us, right? Let's try these two and see which one will actually work for us. All right, so let's first try k equals 3, right? Let's try k equals 3. All right, so let me actually run this thing again. Let me run this. Okay, so let me run this. Yeah, now after we use k equals 3, right? After we use k equals 3, this is what we actually have, right? So let me run this part. Okay, now this is what we have. Let me actually walk you through before we take explanation of this, right? Let me walk you through this. Now, what I'm going to do over here is that don't forget, earlier on we created a model, right? We created a model. So in order for me not to override that model, I'm using a different variable name here. So final underscore model. And then over here in my k means algorithm, right? I'm putting in 3, right? 3, meaning that my k equals 3, right? My number of clusters equals 3, right? So instead of me choosing random k's, now I know which k to use. Okay, now I'm going to use k equals 3 over here. And then I'm fitting it, right? So you see that I'm fitting it on my text subscaled data. Okay, then after that I'll use it to make some predictions using the predict, right? So I'll pass in my data, right? And then I'll store everything in a variable called prediction, right? So I'm making predictions over here to see which cluster I'm supposed to put which complaint, right? So if I should show you which what is actually contained in this cluster, right? What is contained in this prediction, right? So let me copy this and then come down here and then show you what is inside this predictions. Now you can see that I have some predictions here, right? Remember that we are using k equals 3, which means that we are going to have this, right? We are going to have 0, 1, and then 2, right? That's how it's actually going to group it, right? That's 3 clusters. That's cluster 0, cluster 1, and then cluster 2. Okay, that's what is actually going to happen over here. That's why I have some predictions of some going into cluster 2, some going into cluster 1, some going into cluster 2, cluster 0, cluster 1, like that. Okay, so that's basically what is contained in these predictions. Now, if you come here, right, what I'm going to do is that I'm going to create a new column called clusters, right? That's what you can actually see over here, right? I'm going to create this new column called clusters, and then I'm going to put these predictions, right? These predictions over there, right? I'm going to put these predictions inside there. So that's why you can actually see it over here, right? So don't forget that after that, I'm just seeing only the head of it, right? So that's why you're seeing only the first 5 rows, right? That's why you're seeing it. Now that this is done, right, let's go and then see which complaints are in cluster 0, which complaints are in cluster 1, which complaints are in cluster 2. All right, so let's see how this is done, right? Let's see how this is done. So let me run this again, right? Let me run this again and then come here and then show you which let me maybe start from cluster 0, right? So over here, what I'm going to do is that if I go to my cluster column in text sub df, right, I'm going to see which ones are equivalent to 0. That's which complaints, right? Which complaints will be in cluster 0. So let's do that, right? So if I run this now, you can see which complaints are there, right? So you can see that I have cluster 0 over here, right? So let me actually do it this way. You can see that all the clusters here are 0 because I'm selecting which complaints are in cluster 0. Okay, so you can see it over here. Now you can see that and by the way, how we do this, I mean, we talked more about this in the pandas class, so I'm sure you're familiar with this, right? If you've not watched the pandas video, I entreat you to actually go through that, because there's a lot of things that we did in that, and I'm sure if you've gone through that, this is, I mean, easier for you to easily get it. Just selecting, going to the cluster column, and then selecting every item that is equivalent to 0, right? So you can see we have only zeros being selected here, all the clusters that are 0. Now let's see the kind of complaints that are in cluster 0, right? So after our model has learned from these attributes, right? After our model has learned from these attributes, what it came up with is that if we take these complaints: forgot mobile app password, AC stops abruptly, app hangs while entering commands, reinstalling the app hangs the phone, mobile screen bangs on use of phone, right? AC remote does not work. So you can see that most of these are related to phone complaints, right? You can see most of these are just related to phone complaints, right? So related to phone complaints that have been grouped together for me, right? So these are complaints that have been grouped together in cluster 0, right? So let's see those that are in cluster 1, and then see I mean the difference in those complaints. So let's see if we go to cluster 1, right? So this is cluster 1, as you can see over here, right? So I've changed it from cluster 0 to cluster 1, right? So if you see here, right, we have this, and you can see that the clusters that we have now are all in cluster 1. Now let's see the kind of complaints that come into cluster 1. So power cord does not tightly fit, right? Main switch does not on, right? Cluttered with pop-up messages, motor noise from the system, battery backup does not get fully charged, battery does not last full, fan speed varies on its own. So these are just some of complaints that are related to each other, right? The power complaints, mostly it's just about power, some battery, some battery stuff like that, right? The switch, you see that power cord. So mostly it's about power complaints, right? Those complaints are related to power. So we can assign a person to this kind of complaints, right, from the technical support team to deal with these kind of complaints. Right, so as soon as these kind of complaints comes, we will redirect these kind of calls to that particular specialist in the technical support team, right? So that person will actually deal with this, right? And then those complaints in cluster 0 will also be redirected to one person to also, I mean, another person who specializes in that area to deal with it. All right, so now let's see those that are in cluster 2, right? Remember that we have 3 clusters, that is 0, 1, 2. Okay, so let's see those that are in cluster 2, right? So if we see those complaints in cluster 2, right? Those complaints in cluster 2, right? You can see over here that we have only 2 clusters, the complaints in cluster 2. Now you can see that we have what? Temperature control, fan, right? App takes long time to initialize, unable to connect to the app, AC controller software, remote keys get stuck, unable to operate menu from remote, refresher, hold stack Wi-Fi. So we can see how related these problems are. Mostly it's about the temperature, the fan, something like that, right? Some apps, right? Some app, and then you can see remote keys over here, right? Unable to operate menu, right? Freshener, holder stack, Wi-Fi. So these are common complaints, right? These are common complaints that have been actually grouped together, right? So this could be also assigned to another technical person to also work on, right? This could be assigned to another technical member or person in the tech support team to also work on. So someone will be working on complaints in cluster 1, in cluster 0. Someone will be working on complaints in cluster 1. Someone will be working on complaints in cluster 2. All right. So that's what our algorithm will help us to actually divide these complaints, right? So that we will assign different persons to be working on these different problems. All right. So this is one we did for three clusters, right? So let's go and see how we can do the same thing for say 5 clusters. Remember that over here we actually concluded that it's possible our k, right? Our k can be, the best k can be say 3, and the best, or it can be 5, right? It can be 5. So let's test the 2 and then see which one is actually grouping these or clustering these complaints better. So now let's now consider k equals 5 and then c. So the same thing that we did here, the same way that we built the same thing. The only thing that we're going to change is this 3 to 5. Okay, that's the only thing that we're going to change. That's the 3 to be 5. Right. So the same thing, fitting our model, right? Fitting our model, making predictions, right? To store all the predictions in a variable called predictions. Okay. Then after that, as you can see over here, right? So let me run this thing again. Okay, then run this one. Now you can see over here, right? So I'm creating another column, right? I'm creating another column because this one is actually going to override the one that we were doing over here, right? It's going to override this one. So I'm doing everything again, right? I'm doing everything again. So this cluster will come here, right? This cluster will come here, and then I'm just seeing the first 5 rows, right? This is just to print. Just to print this thing, like clusters assigned. That's what you're seeing. Okay, now after this is done, right, we have our clusters. That's so in this case we are choosing k to be 5, which means that we are going to have 0, 1, 2, 3, and then 4. That's 5 different clusters, right? 1, 2, 3, 4, 5 different clusters. Okay, so now let's see those complaints that are being clustered into cluster 1. Those are in cluster 2. Those that are in cluster 2, cluster 3, and then cluster 4. All right, let's see what we have in there. So let me run this again, right? Run this. Okay, over here I'm just picking only the clusters, right? I'm picking only the cluster, the complaint type. So let me get rid of that, and then later on I'll come back and show you what I was doing over there. All right, so let me run this again. Okay, now you can see what we have, right? You can see what we have over here. Let me bring this and get rid of that. Okay, now we have our problem type. We have our problem type here. We have our clusters, right? We have our clusters over here. Okay, don't forget that we are doing it for complaints that are in clusters and cluster 0, right? Now we have cluster 0, 1, 2, 3, and then 4, right? Because we are choosing our k to be 5, right? So that's what we are going to have, 5 different clusters. All right, so we are seeing those complaints that are in cluster 0. Now you can see that we have AC stops abruptly, apps hang while entering commands, right? We have reinstalling the app, right? Mobile screen. So you can see that most of them are mobile complaints and some app complaints, right? Some app complaints, and then the AC, right, being put together in one group for us, right? In group 0, right? So I mean, basically this is what the first cluster contains. These are the complaints that the first cluster contains. All right, let's see those that are in cluster 1. So let me change the 0 to 1. Okay, and then let's run it and see. Now you can see that we have over here, right? Let me do this. Over here we are talking about the cluster 1, right? Because we've changed it to 1. Okay, you can see the complaints here: temperature control not working, fan string not working, forgot mobile app password, app takes long time to initialize, AC controller, software missing, freshener. So it's almost same as the one we were dealing with when our k was equals to 3, right? I mean, it's almost the same when k was equal to 3, right? It's just almost the same thing. Just that we have several clusters in here, which means that the complaints are also going to be divided into smaller complaints, right? Into those different groups, right? So let's see those that are in 3, right? I mean in 2, because this is 1. This is the second cluster. So let's see those that are in cluster 2, right? Let's see that's 1. So you can see that here, this is one you have to take notes. This is one you have to take notes and see which one is actually doing. When we do cluster 2, right? When we do cluster 2, you see that we only have 2 complaints, right? Power cord does not tightly fit. main switch does not on. Although these are complaints that are related to each other and they've been able to correctly group them together, right? But you can see that we have only 2 complaints, and it will be if we want to assign a person to just sit down and then be working on only these 2 complaints, right? Whilst someone who is working on other complaints can also do the same kind of work. So we don't actually need to employ another person and be paying him to just do only this. Right, so here our model will actually make us bear more cost if we are going to consider k equals 5, right? Our model will make us go and employ another person to come and deal with these kind of problems, right? Which is actually going to give us more cost because we have to pay that person, okay? Whilst there's someone in the technical team already who can do this kind of work, right? If you consider what we were having previously, right? If you consider what we were having when k equals 3, right? These problems, right? Power cord does not tightly fit, main switch does not fit, was actually grouped into another group, right? Within the 3 that we're having, right? We're having those complaints, right? We're having those complaints being grouped in one of them. Don't forget that this has been overridden, so even if I run it, it's actually going to show the same thing over here because we have already override this, right? So I cannot do this one again, but you can run from the beginning again and you can see where this complaint was, right? Where this complaint was. Now, this is actually something we don't need to do because only 2 complaints in just one group, and then we want one person to sit there and then be working on this. No, we want it to be at least 4 complaints in one group. Maybe it's okay, right? At least 4 complaints in one group is quite okay. Let's see those complaints in say group 3 and then see, right? Maybe this one is good, right? So if we assign a person to be working on these complaints, is quite good, right? It's quite good, and because we don't want to employ so many people and be paying them whilst a few of them can do all of these work, right? So let's see those that are in the last group, right? You can see that those that are in the last group, we have cluttered with pop-up messages, motor noise from the system, battery backup does not get fully charged, battery does not last full 8 hours, fan speed varies on each one. So you can see the kind of common complaints that have been grouped into this cluster for us, right? That is cluster 4, right, for us. All right, so basically this is what you're supposed to do. So in conclusion, we can say that the cluster 3 was actually doing better for us because we cannot actually afford to include that cluster 2, which contains only 2 complaints over here, right? We cannot afford to assign a person to be working on this, right? So I think cluster 3, I mean using k equals 3 is actually working for us. It's actually working for us. So we will consider k equals 3, and then proceeding from here we will use k equals 3, right? We will considering k equals 3. All right, so basically that is what. Don't forget that in this case we did not have a target where we're trying to predict, right, whether a cell will be cancer, right, whether a cell will be cancerous or not, right. Don't forget we're not having that kind of a situation, right. What we are trying to do over here is to group certain complaints into groups, okay, and that's why we are using k-means. We're using k-means clustering, right, to cluster these complaints into different groups. So we're having cluster 0, cluster 1, there will be another cluster, say cluster 2, there will be another cluster, say cluster 4, right? So if we are choosing our k to be, say, 3, then we will be having these 3 clusters, that is from 0, 1, and then 2 over here, okay? So in this case, we are not predicting something like this, right? We are where we have a supervised machine learning problem, right? And then we try to predict the target. No, in this case, we are trying to group items into similar groups. We don't have any target. This is an unsupervised machine learning problem, right? And k-means is an unsupervised machine learning algorithm, right? And that's why we're using it in this case. So I hope you have an intuition of how the k-means algorithm works, right? And you will be able to work alongside, you'll be able to practice alongside. All right. So in the next video, we're actually going to consider the hierarchical clustering, and it's also going to come with its own lot of concepts that we need to get to learn, and it's going to be fun. So see you in the next video. Have a nice day.